Hello, welcome to Math 1324. This is Chapter 4, Section 2, Example 3. I missed my chance to say 2-2. Anyway, for this example, we want to use the simplex method to solve the linear programming problem. We're going to maximize that objective, subject to some constraints, with x1 and x2 both being greater than or equal to 0. By now, I think you understand the process. So the first thing we're going to do is realize that this is going to give us an S1, this will give us an S2, this will give us an S3. So putting this into a system of equalities, that's going to give us 5x1 plus x2 plus s1 plus 0s2 plus 0s3 plus 0z, all equal to 40. For the next one, we have 7x1 plus 2x2 plus 0s1 plus s2 plus 0s3 plus 0z is equal to 60. Then, of course, we have x1 plus x2 plus 0s1 plus 0s2 plus s3 plus 0z is equal to 50. And then, of course, make sure we move our variables to the left-hand side, making that negative 2x1 minus 7x2 plus 0s1 plus 0s2 plus 0s3 plus z, and all of that's going to just equal 0. So there you go. That's going to be our system of equalities that we need to solve. All right. Our initial simplex tableau, the size of it's going to be 4 rows by 7 columns. So this will be a 4 by 7 matrix, which will be 28 different elements, which are 5, 1, 1, 0, 0, 0, 40, 7, 2, 0, 1, 0, 0, 60, 1, 1, 0, 0, 1, 0, 50, negative 2, negative 7, 0, 0, 0, 1, 0. Okay, good deal. That is our initial simplex tableau. But once we have that, we need to figure out our pivot. Now, our pivot column is going to be represented by the smallest, the most negative number, I should say. The smallest number, aka the most negative number of the indicators. Now remember, the indicators are these down here, not including the 1 or 0. So it's these 5. Now 0, 0, 0, they're not negative, so they're not part of it. Negative 2 and negative 7 are both. The most negative is the negative 7. So this second column is in fact going to be our pivot. Okay, so that means that this is our pivot. Excuse me, it'll be our pivot column. Then we need to figure out our pivot row. To do that, we do division. 40 divided by 1 is 40. 60 divided by 2 is 30. And 50 divided by 1 is 50. Of these quotients, which one is the smallest positive? Well, 40, 30, 50, the smallest is 30. That means that of these, this is the pivot row, which indicates to me that your pivot is right here with this 2. Okay, so that, remember, this is the second row, second column element. Alrighty. Now that we know all this, we can go to our calculator and use it to go ahead and pivot the actual matrix. I'll see you there. Welcome to the calculator. Let me go ahead and clear everything here. Let's go back into matrix. Now, remember I said last time that it doesn't matter if you delete these or not. I'm not going to delete it this time. So I'm going to edit matrix A. We always want to edit matrix A. So on this matrix, it's a 4 by 7 matrix. So we're going to type in 5, 1, 1, 0, 0, 0, 40. Then 7, 2, 1, 0, 1, 0, 0, 60, 1, 1, 0, 0, 1, 0, 50, -2, -7, 0, 0, 0, 1, 0. Awesome. Quit to the home screen, and then let's go ahead and look at the matrix again, just to make sure that it is correct. 5, 1, 1, 0, 0, 0, 40. 7, 2, 0, 1, 0, 0, 60. 1, 1, 0, 0, 1, 0, 50. Good. -2, -7, 0, 0, 0, 1, 0. Awesome. As we found last time, this number 2 here is going to be our pivot. So let's go ahead and go into Program Pivot. Click Enter until we get to the pivot row here. Now, again, this is the matrix in A. So the pivot row is the second row, which is second row, and the pivot column is the second column, which would be that 2 there. There we go, and it's done. To see the matrix, we have to go back into matrix A. And there you go. Notice that you have a 1 and zeros above and below. Awesome. Even better, if you notice, there are no more negative indicators, which means, believe it or not, we're actually done already. Good deal. So let me go ahead and write this matrix down. Let me convert this to a fraction. There we go. So we have 3 halves. I'm going to go vertical. 7 halves, -5 halves, 45 halves, 0, 1, 0, 0, which is the reason that all this happened. Then we had 1, 0, 0, 0, -1/2, 1/2, -1/2, 7 halves, 0, 0, 1, 0, 0, 0, 0, 1, and 10, 30, 20, 210. Outstanding. Alrighty, I'll see you back at the notes. Okay, welcome back to Math 3. Okay, welcome back to the notes. You should see the matrix that we saw just a second ago. And I'm going to go ahead and label everything as X1, X2, S1, S2, S3, and Z, just above these. So X1, X2, S1, S2, S3, and Z. Good. And that is going to allow us to write down the solutions. Awesome. On this, notice that X1 and S1 are both 0. x2 has a 1 here, so it's equal to 30. S1 has a 1 here, so it's equal to 10. Sorry, the S2 was 0, not the S1. S2 we already saw was 0. S3 has the 1 here, it's equal to 20. And the Z has the 1 here, it's equal to 210. Alrighty. Believe it or not, that is the solution. In other words, if we're trying to maximize this objective subject to these constraints, with S1 representing this inequality, S2 representing this inequality, and S3 representing this inequality, then we should have none of x1 but 30 of x2, and then we're going to have left over 10 of whatever S1 is representing, nothing of what S2 is representing, and 20 of what S3 is representing. Then, of course, that means that the maximum for the objective is 210, no matter what the Z is actually representing here. Now, of this, what you should realize is that, believe it or not, S2 is what's considered the limiting factor. It's the constraining factor here, because there's nothing left over of it. If we had more of it, we could have gotten a larger objective. The reason that I know that is because it has a 0 there. Because it has 0, there's nothing left over for it to be used, so that's the limiting factor. Alrighty, well, I'll see you in the next video. Have fun.